Moving right along, and quarter number 1 brings us to standard number 5, which is transformations. Transformations means that something is going to move. It's going to change its location, and we're going to change its location by using 3 different methods. A reflection, which means a flip. So I have my blue piece of paper that hopefully will show up nicely against the white background. I cut the corner off it so you can understand, you can see that when I move it, how it moved. It'll be easier to see, just trust me. So a reflection, I said, was a flip. So to flip something, it actually comes off the page, and if this was the front, you're going to flip it over to the back. I could even write an F and a B on there if that makes it easier to see for front and back. So a reflection flips something specifically across the line, but we will get into that more tomorrow. For now, I just want you to know the basics of what a reflection means is to flip from the front to the back side. So when you flip it, the corner that was cut off was the upper right. You flip it, now it's in the upper left. That's what happens with a reflection. All right, the next one was a rotation. The best way to describe a rotation is a spin. All right, so you can take this same piece of paper, and instead of flipping it, we're going to rotate it, which means we're going to spin it like this. So the corner that was cut off, again, I'll start in the upper right-hand corner. When we spin it, now it's in the bottom right-hand corner. Or you could spin it counterclockwise, and it'd be over here in the upper left-hand corner. But that's another way you can move an object, is by spinning it, which we call a rotation. And then the third way for now that we can move an object is to translate it. And you can see I wrote translate means slide. So when you slide something, all we're doing is sliding it across the page. And it doesn't have to be straight across. It could be at an angle. It could be left. It could be in any direction. But the upper right-hand corner that's cut out is going to stay in the upper right-hand corner. We're not spinning it, and we're not flipping it. We're just simply sliding it. And that's the one that I want to focus on today. Before I get into a little more detail on translations, you might have noticed I had a couple more words written on my whiteboard. Orientation and isometric. All right, orientation, I wrote same direction, and isometric, same size. So let me explain that a little further. All these 3 transformations that I just showed you did not change the size of this paper. Whatever the dimensions are of this paper, whether I flip it, rotate it, or spin it, I'm not a magician. I'm not shrinking this paper or making it bigger. I'm just moving it around. That's isometric. That's why I say same size. The size doesn't change. Now, there is a transformation that changes the size, and that's called a dilation. Like the pupil in your eye can dilate, it can get bigger or smaller, but that's not for a few standards down the road. We don't need to worry about that now. So everything we're doing now in this standard is isometric. We're not changing the size of it. What we are doing on most of them is changing the orientation. So for example, my orientation is facing in this direction. Now I'm facing in the opposite direction. I changed my orientation. I'm not facing the same direction anymore. But I'm still isometric. I didn't change my size. I'm still the same size. I didn't shrink or get taller. I just changed my orientation. So a reflection does not preserve orientation. The corner that was cut off was in the upper right-hand corner. Now it's in the upper left-hand corner. It'd be like me. I'm facing you, then I reflect, now I'm facing the board. That's a different orientation. So reflection does not keep orientation. Same with rotation. Right now the F is facing up like you would normally see an F, and if you rotate it, now the F is sideways, laying on its side, it's upside down. It's got a different orientation. Translation, what we're doing today, does keep orientation. The F is pointing up, the top right-hand corner is out. If I slide this, that's still the case. The F is still pointing up, the top right-hand corner is still cut off. No matter where I slide this, the orientation is the same. It's still pointing up. The F is still upright. All right, if the F's not upright anymore, that means I rotated it, and that's no longer a translation. A translation does not spin it at all, just slides the whole object. So they all are isometric, but only one keeps the orientation, and that's a translation. Now, to further describe a translation, we need a coordinate plane, because if I start off here and you take a picture of that and I slide it over here and you take a picture of it, your pictures are going to look exactly the same if you just focus in on the piece of paper. So how are you going to know I translated it? It's got to be on a piece of graph paper. That's how you can tell. So we're going to draw a little graph paper. I'll draw, that's my blue paper with the corner cut off. It's kind of a bad drawing there, but work with me on that. All right, that's where we're going to start. So this is going to be our starting point. That's where we're going to start from, and a starting point is called the pre-image. And then say I'm going to slide it over to here. That is going to be our end point, and that is going to be called the image. So that's more vocabulary. Yay, I know you love vocabulary. Haha. Pre-image and image. How do you know which one's which? Well, pre means before, so you start before you end up somewhere. So pre-image is where you start from, image is where you end up at. There's another way to tell. Sometimes it won't always say this is where we started from, or this is the pre-image, this is the image. Sometimes it won't give you any words at all. It's just going to give you letters on the vertex of your shape. So we'll call these corners A, B, C, D, and E. Now that's the pre-image, just regular old letters. The image over here where we end up is going to have a little prime mark and a little apostrophe. A prime, B prime, C prime, D prime, E prime. All right, that's another way to designate image to pre-image, where you started from, where you ended up. You start with regular letters, and as you move, your letters get crazy, and they get a little prime mark by them. All right, so that's another way to tell. And finally, what you need to know for this standard is how far you're supposed to move this shape. So I'm going to put a little bit more of a simpler shape on there for you, and I'm going to use a right triangle, and I'm going to put it right here at -2, -5. We'll say this is 1, and this is 6. All right, so this will be the point -5, 1, -2, 1, and -2, 6 would be our three corners, A, B, C. I got a little cramped in there, but hopefully you can see all that. I'm just trying to give you a starting point. A right triangle, I'll even put the little right triangle. You don't need that. All right, so we've got three vertex, 3 points of our triangle, A, B, and C. -5, 1, -2, 1, and -2, 6 is point C. Now, I'm going to say, okay, move this by the vector 4, -2, and you're going to look at me like I'm crazy. What does that mean? Well, I just used another vocabulary word, vector. Vector is just, it's really a physics term, and it's kind of like force. It's kind of like a direction that you push something. It's not really, maybe force is a bad way to describe it. It's more like direction. So a vector is pushing something, moving something in a specific direction. So we're going to use vectors to slide this in a specific direction, either left or right, that's our x direction, or up and down, that's our y direction. So we need two numbers to say how we're going to move this. We need an x and a y number. So say we want to move it to the right 4 spaces, we're going to say 4, and if we want to move it down 2 spaces, we're going to say -2. 4, -2, but instead of making that an ordered pair, it's going to be a fancy parenthesis. It's going to be like a less than and a greater than parenthesis, but that just designates that it's a vector. So vector starts with a V. These are kind of like sideways V's. Maybe that's a way to remember it. But all that is just like an ordered pair, an X direction and a Y direction. If it's positive, you move it right. If it's negative, you move it down for your Y. Just dealing with the X, positive and negative. If the vector is positive for the first number, you move it right. If it's negative, you move it left. The second number is your Y direction, up and down. If it's negative, it moves down. If it's positive, it moves up. So let's use 4, -2 on this one and see where we would end up. If we got to move, I'll take point B first. What's 4 to the right of -2? 1, 2, 3, 4 spaces. That would be at +2. And what's 2 down? That would be right here at -1. We started at +1. We're going down 2 spaces to -1. So that's our new point B, would be the coordinate 2, -1. All right, we added 4 to -2 to get +2, and we subtracted 2 from 1 to get -1, because remember, that's our vector, 4, -2. All right, you do that with all the points. What if you add 4 to -5, you end up at -1, and you subtract 2 from -1, you end up at -1 right here. So this is our A, that is -1, -1. And then C to the right, 4 spaces from -2 is at +2, and down 2 from 6 puts you at 4, 2, 3, 4, 5 right here. So that's our new C, 2, 4. All right, so then you could draw your little shape. Now, these aren't A, B, C. Remember, this is our image now. Now we've moved it. These become A prime, B prime, C prime. All right, and that's translations. That's how you slide something. You either slide it left or right in an X direction, and you slide it up or down in a Y direction. The biggest mistake I see on these types of problems, let's say that these weren't the primes, these were the primes. People are so used to reading from left to right that they look at this picture and they automatically think that the triangle started here and moved to there because your brain is programmed to go from left to right. But that's not necessarily the case with these. You go from the regular letters to the prime letters. So if the regular letters are on the right and the prime letters are on the left, that means you slid to the left and up. So that would make this a -4 and this a +2. Like from A, you went from -1 over to -5. That was left 4 spaces, -4. And you went up from -1 to +1. That was up 2 spaces. All right, so you got to pay attention to your primes. Because a lot of these problems, they'll give you both pictures and they'll ask you what was the vector. So you got to know, am I going left first or am I going right first? Where did I start from? Find your starting point first. Find the letters that are regular letters, not the prime letters, and you'll do fine on this